Oh, hello, hello. We're going to go for a fairly casual start because we're still waiting for the pizza, but we'll kind of kick things off. Who's already a member of the Databricks Meetup? Who's never been to a Databricks Meetup? Oh, new people. Hi, welcome. We don't normally do it here, obviously. What we do is every 2 months, we do it in the Databricks HQ around Fitzrovia in London. So that means today is a very special one, and then the next one's probably going to be around November. We've not announced it yet. But go on meetup.com, join the London Databricks Meetup, and every 2 months we get together, we have some beers, we have some pizza, and we talk about tech and Databricks and what people are doing. That's the general plan. So welcome new people, hello returners, all that good stuff. And yeah, so the plan today, we got the lovely Holly, who's going to be talking about Databricks. So it's going to be an interesting topic where the slides are great. And then after that, we got Gavi talking about some of the newer things in AI inside Databricks. There's a bit of a theme of Databricks. And then we'll kind of hang around for a bit of a Q&A, ask us any questions, we'll chat about stuff. Feel free to hang around and drink beer and eat pizza, and that's generally the plan. Sound good? Okay. So do I keep stalling for time, or do we just start? Stall for time? No. All right. Holly?
Good evening, everybody.
Hi, Holly.
Thank you. Excellent. Wonderful. So I lied a little bit earlier, I'm afraid. I'm not really going to be talking about Databricks. I'm instead going to be talking about table formats. Oh, how exciting. All right. And so a lot of them are driven by metadata. And I also want to say thank you for coming to this non-AI talk today. Specifically, this talk is around data storage, which is confirming all rumors that, yes, you are, in fact, all nerds. So why do we want to talk about storage? Kind of conceptually, I think humans understand storage. You get the stuff, you put it in a place, bam, it's stored. And I'll be honest, I didn't really think about storage for a very long time, for like the first decade of my career, ultimately. But then everyone started talking about it online. I thought maybe we should take a closer look. So who better to talk you through table formats than me, Holly Smith, not an expert. Why do I have the audacity to stand up here and talk about table formats? I have a few qualifications, I have a few things going for me. First of all, experts are actually quite hard to understand. Every time you listen to an expert, you kind of maybe get like 10% of it, and the rest of it, you're like, oh my God, what you want about? And that's because they have so much understanding that they just assume everyone has as much as they do. So let's start off. I don't have a computer science degree. I'm not going to assume that you have one either. Now, I have worked for Databricks for about 7 years now. 5 of them was in our consult. No.
The exhibition has now closed for the evening. Would any remaining visitors please make their way to the exits? The exhibition has
No,
closed.
stay.
Thank you.
Ignore the instructions from the Lady of God. Okay then, so yeah, I have worked at Databricks for quite a while, and yes, I have been a practitioner. I have used it hands-on, Delta and Iceberg quite a lot, but no, I'm not something like a contributor. But I do have great respect for those who we are all indebted to people who take a lot of their free time to contribute to these projects. And if there's anything that you take away, please don't take away that I'm disparaging any of these projects. I do have great respect for those who are, but I am not one of them. But despite this, I do have a few advantages for me. And for those of you who know my work very well, you will know that I can read. I read the Delta books, I read the Iceberg books, and also the One House early release of the Hoodie books as well. I have also read the documentation, novel as that is, to get to the bottom of some of the really nitty-gritty bits. I also have access to all the experts as well. Working at Databricks, I can ask all these people questions, and I can annoy the hell out of them because I have no shame. I can just ask questions, and I can just keep on going. So before we get into this, we are going to be talking about some fairly technical things this evening, and they are quite complicated. And so to benchmark how complicated something is, we will be using the international standard, the Nando Spicy chart. No one is going to blame you if you can't manage an extra hot, because I can't either, and we won't probably spend that much long on it either. And I'm also going to summarize everything at the end. So if there are some things that are like, Holly, I'm not really feeling a hot today, that's okay. We'll come back to mild later. So let's start off easy. How do we get ourselves into this scenario anyway? First things first is bigger data. It is getting bigger all the time, and with the eponymous AI, it is also getting much bigger too. We're also getting faster data as well. Analytics has always had a slight delay, but not so much business applications, and the tolerance for how long people wait is getting smaller and smaller over time. Finding the data, just like absolute plethora everywhere, and I mean that in the truest sense. Trying to find out what you actually need, really tough. And finally, with the advent of things like Hadoop and Cloud and Spark and all of that kind of jazz, having something that's actually usable, that is ready for you to get hold of, is incredibly tricky. And something I want you to just keep in mind is throughout the history of data, these things have always been a problem. And it is always going to get worse. Now I know what you're all thinking right now. You are thinking, Holly, what's wrong with Excel? Okay, so let's think about this. What is it that we need from a storage format? So you want things like, how fast is it to read? How easy is it to persist to disk? How big is it when you save it? You know, storage is fairly cheap these days, so it's not a huge concern, but you don't want any size explosions. And once it's on the disk, you will want to make changes without reading it all in and writing it out again if all you wanted to do was change the name of a column. And then finally, how plug and play is it as well? If you want to use one particular storage format with another particular engine, how easy is it to do? And so before we dive into all of these things about table formats, we are going to start with a bit of a primer, and that is an old-fashioned version of file format, and that is Parquet. Let's be honest, who here has used Parquet before? Everybody, nearly everybody. Excellent. It is prolific. It is supported by all three projects that I'm going to talk about. Now, when I had this talk in mind, I was like, you know what? We're going to go into the nitty-gritty of Parquet. I'm going to show what it looks like on disk, and then we'll go through it from there. It turns out actually like this. It looks like this on disk. This is just a bunch of representations, and I don't fancy going through this. So instead of excavating this, we are going to use the representations. And spoilers, it's all segments and metadata. So if we have a Parquet table like this, which I believe is a very handy table of Nando's branches, the first thing we're going to do is subdivide into these horizontal chunks of data, into these row groups that we have here. So they're the horizontal sections. And now you might be thinking, why bother doing this at all? Why bother start segmenting anything? And that is a fair question. As we start to subdivide our data, we can start to do things in parallel. Instead of having one machine in one table, why not have 10 machines all do different things in parallel? And so to do that, you need to start subdividing, and that is where the first big subdivision is. The next layer down is our column level, and this is where the phrase Parquet is a columnar data type comes in. The items within these columns are stored next to each other on disk for speed of retrieval. Now, I've shown you this with 5 records in it, but realistically, it's going to be much bigger than that. And still, that's not quite small enough for the data that we need to use, so we're going to subdivide it into one level further and go to pages. I promise you this is the smallest amount of subdividing we're going to do. And this is where the interesting things start to happen. It is where we find our first piece of metadata. So associated with this metadata, this page metadata, we have things like summaries of this data. So we've got the size when it's compressed, when it's uncompressed. Where are they all on disk? We've got some statistics like minimums and maximums. We've got some various binaries in there. We've got things that we need for data skipping as well. And you will notice throughout this entire field that when we have a data storage problem, the answer is always going to be metadata. So when I say data storage problem, you're going to shout metadata, right? We're gonna do this again. So we're going to do this. So I'm going to say data storage problem. You know what? I think by the time you get to the end of your beers, you're going to really get this. Okay, excellent. So now this is still a diagram. It's not what it looks like as like a hexadecimal values on disk that we saw earlier. So instead, when we have it on disk, it's going to look like some mumbo jumbo like this. And so the bits in gray are the actual data itself, and nestled in between our pages of data is the metadata. Now, can anyone see a problem with this? One guy shrugging. Okay, that is, if you want all your metadata, you're going to have to scan through all of this. So we have a big data problem. That's right, we're going to have more metadata about our metadata. And at the end of our Parquet file, we're going to add in some more metadata, and we're going to have a lookup of where all of our metadata is. This is called a page index. Think about it. The smallest chunk we had as a page, this is an index of where all the pages are. And we can also make our page index do some very clever things. Who here has heard of a bloom filter? Cool. Like 5 of you. Okay. So these are probabilistic filters. So they'll bring back everything and more. And you might think, hey, that's not very useful, Holly. But if you're doing like needle in a haystack type things, this is where these bloom filters are really useful. If you need to bring back like 0.1% of your data, do it really quickly, you need a bloom filter, even though it is a bit fuzzy. In terms of the trade-off here, you say how imprecise you want it to be. The more imprecise, the faster it is. And so when it comes to doing that, what we're going to do is instead of having our data stored, if we did it on our branch ID here, instead of having this nestled throughout our entire Parquet file to do all of our filtering on, actually, why don't we store a copy of this bucketed in groups in our metadata? This is quite advanced. I'm not going to dwell on it too much because, frankly, you don't need to know all this to use it in real life. But this is one of the fancy things that Parquet can do. Now, we have lots of metadata about our tiny pages, but what about the whole file? So again, we have a data storage problem. Hey, you guys are getting this. All right, so what about metadata about the entire file itself? This is things like the Parquet version, how many rows we've got, what does the schema look like, what are the date that we created it, who is the one who went about and created it. And that's nice and all, but it doesn't tell us about the columns, so we have a data storage problem. I wonder how long I can drag this joke out for. Yeah, that's right. We're going to do this for columns as well. For each row group, remember that's the biggest unit that we've got. We also have the metadata in there too for the columns that breaks into the column groups we know that we've got in our table. So, to summarize, metadata. Now, Parquet is only a not the only storage format out there. You might have heard of ORC and Avro, and they're kind of similar. So the first thing about this is ultimately the first level of segmentation. We've got wide data, or we've got narrow, which is better for I/O. And I'm going to be honest, this is really boring. This is quite in the weeds about like why these things are different. We've got like the second layer. Some people have bloom filters and some people don't. And some people stick some things together and others don't. It's not really that important. And I'm guessing that most of you who've been using Parquet have not thought about these things when making that decision. This is telling, foreshadowing. Okay then, so that are some of the options that we have. Now, if we remember our original list of what we wanted a table format to do, let's assess how well Parquet does this. So first of all, speed of retrieval. So one of the things that we can do is we can do something called predicate pushdown, where we are, instead of scanning the data itself, we're just going to scan the metadata and try and get that as fast as possible. We also have things like predicate pushdown. So if we want to be, sorry, this is my beautiful diagram of a cluster. I hope we can all appreciate that. Thank you. Thank you. Someone's nodding. I like you. And so when we've got multiple machines, we can start doing things in parallel. We can also start doing parallel writes as well because we've got different sections of our group. In terms of the storage size on disk, we can do some interesting things with compression and number representation. Instead of just copying things over and over again with our multiple times, we can just have a dictionary lookup. We can also have it as a hash as well so that we can find it much faster too. We can also do some data flexibility with some quite clever things around the schema. So if I just wanted to add on another column that's got nothing in it, that's a bunch of nulls, I can just add it to this metadata here rather than reading in an entire table and writing it out again. And finally, add remove columns. Yep. Okay, so no one's asked this yet, but what is wrong with a database? So they are great for BI, fair enough, but they're kind of terrible for everything else. I hate to say it. And for me, the glaring thing is that they're normally not great ecosystem players. Now, whether they are open source is kind of debatable. There are some things out there like Postgres, which big tick, open source, but there's lots of other database providers out there that aren't. And that is kind of a bit of a problem, because if you wanted to use a new engine, you can't just go and build that integration yourself. You are dependent on what the providers have made for you. Similarly, it's also SQL heavy as well. So if you're doing any of that fancy AI stuff, you're going to struggle here. And finally, the language as well. Oh, sorry. I've got Metastore in here. Oh, interesting. So a Metastore is more like a reference library about like what data refers to what particular thing. And with a database, you are very coupled in there. OK, then. So how does Parquet solve all of our data woes? Oh, it does a pretty good job, actually. And so here's a nice summary of everything we have. And so I hope you are all in agreement that for your data engineering projects, that Parquet is much better than Excel. OK, then. So why did Parquet stop there? Why have we got this kind of proliferation of projects in the open source world to solve our data problems? Why did Parquet, as a project, not go out and do this? Now, I couldn't find a direct quote for this. I read something about like wanting to go into like GPU spaces rather than go into these other things, but I couldn't find it. If you found one, please tell me. Where does a file type end and a new technology begin? So there are multiple ways that we can solve this, and there's a lot of language out there and the way that people describe these three projects. I've heard it described as all of these things, but for you today, I am going to stick with the phrase table format over anything else. And so what problems do we still have? Even though Parquet is great and it does so many things, there are still some things that it hasn't quite cracked. And one of those things is ACID transactions and rollbacks. If you have a Parquet job and it fails midway through and it's halfway through a write, I'm sorry, you have lost that progress. You've got a corrupt file. It is an absolute nightmare to go and retry something that is half completed. So when it fails bad. We also have schema enforcement. It's incredibly gullible. You can be like, hey, this is a date, and it's a string, and I'll just believe you. This is a bit of a problem for people who care about data quality. We also have the small files problem. I don't know what that is doing there. Yes. What we've got here is a bunch of Parquet files. And if you've got lots and lots of tiny, tiny little files, you spend more time opening them and closing them than you do actually reading the data inside them. And finally, advanced schema evolution. There's not really a lot that you can do here. You can kind of trick Parquet into like adding a column or renaming it by dropping it and then adding it again. But there's not really a lot more that you can do in terms of changing types and things like that. So how can table formats help? So step one is to version our table. And so here I've got an example where we've got 3 Parquet files, and they are part of version 1 of our table. Now, let's say I go and I add another Parquet file, and I append the data. What I can do is I've got this new version, and I can say that version 1 with 00000. And number 1 and number 2, I'm looking at the part on the left-hand side here. And for version 2, I can say that includes a little bit more. But it's more than just appending data. I can be clever, and I can say, hey, actually, sorry, Australia, we're deleting you. And actually, instead of going ahead and literally removing that data from disk, we're just going to ignore it. And then finally, what we can also do is we can update our files as well. So if I updated South Africa, but I don't want to rewrite out the entire table, again, I could just pop a new version in there and say, hey, this is version 4. Version the table, excellent. All right, so there are some consequences of this. So yeah, we don't need to write things out again once it's already changed. We didn't delete anything. So if we need to go back to that previous version, maybe that South Africa update wasn't what we thought it was, we can easily roll back because we didn't go ahead and delete that data. It is still there. And this mapping of what version of which files should be stored somewhere should be stored somewhere. And that is definitely something we're going to have to consider later. So step 2 is that we also have more metadata. And we're going to start storing a bunch of things. So not only do we have this mapping of this file here belongs to this version, we've got the operations of the things that we've done. Did we append a data? Did we delete something? Did we do a merge into? Are there some better stats that we can get hold of so that we can scan through even more of our data? And all of these things about engine info. And again, having more statistics means that you've got this really kind of turbocharged version where you've got the performance that you might not have got with Parquet alone. One of the things that we can also do is if we have too many of these small files, we can go ahead and right-size them. And so, yes, we're going to read in and write them out again, but we are going to make them the correct size that is going to be better for our performance. This is called compaction, so combining them to be the right size. So again, less time spent on that small files problem where you're opening and closing rather than actually reading. And whilst we've got everything open, we might as well have a bit of a tidy up, right? So we should also try and sort of tidy the data. Let's not get too obsessed about making it perfect because nothing is ever going to be perfect, but we can make it better than random. And then finally, we can delete the stale files as well. If we've done that compaction where actually we've taken our small data and now we've made it a bit bigger, we don't really need all that small stuff. And if you get this really wrong, you can end up with so much time listing files rather than actually reading them. And so we can delete these. Okay then, so let's open table source formats. Time to kick the beehive and just compare all three. So Hoodie was the first one out of the gate. And this was created at the people at Uber who were struggling to process their huge amounts of data. They open sourced it in 2017 with the Apache Foundation. And in 2020, it really became kind of like a top tier project. Iceberg was second off the mark with their project in 2017. This was created by the people at Netflix. And similar to Hoodie, it went to Apache in 2018. And they saw a real explosion in their community in about 2021. And last but not least is Delta, who was made by Databricks. Yes, it's the company that I work for. It was made in 2017. It went to Linux in 2019. They were a little bit sneaky about how they did this. They didn't quite open source everything. And then they realized in about 2021 that no, that was a really dumb idea. And actually in 2022, that's when we saw that massive adoption because they open sourced the full thing. All right, so let's have a look at these in detail. The first thing to decide is where are we going to store all this metadata? I cheekily described it as this earlier, which implies that it's stored next to the data on file, whether that's on S3, whether that's ADLS, whether it's GCS, or whatever. Just chuck it in some JSON and call it a day. But that is not the only way. You could store it in storage like Hoodie and Delta do, but Iceberg chooses to have it in a catalog. And now for this evening, we have to acknowledge that catalogs exist. What is a catalog? This is more metadata. So this maps the file locations to a particular table name that you might have. That's a really basic one. You might have something that's a bit clever that does things like access management or discoverability, cross-platform, not just tables, like a big variety of things as well. Some common catalogs you might have heard of: Hive, Glue, Nessie, Unity, and IRC as well, which is gaining a lot of traction. So how does it work with Iceberg? So all of this metadata is stored within the catalog, and they store the metadata and the list of metadata with the other versions of the metadata in the meta store. Got it? This will be on the test later. Okay, semantic association really kicks in about now. Okay, so let's go through this in detail. So we've got our data files, which technically for Iceberg, they don't have to be Parquet. They could be something else, but for us, let's pretend they are Parquet files. They're our old-fashioned data. There's a manifest file that's got where these particular files are, some partitions, and some stats about it. We then have a manifest list, which says which snapshot relates to which version of which file, and then finally a metadata file for the snapshot version, definition schema, and the partition. When you go home this evening and your other half asked you and said, hey, darling, how was your evening? And you're going to say, sorry, I was late home, darling. I was learning all about metadata storage and catalogs. That's how I know you're all nerds, because you've stayed. OK. All right, in terms of where to store the metadata, yes, Iceberg does have a catalog, and it's got it in this very kind of specific way. Hudi has something called a timeline, and this is a way of monotonically increasing logs or commits that they've got to something called a timeline, whereas Delta has logs. In terms of the format of the logs, there's a bit of variation there. But in terms of the pros and the cons, here's what I want you to keep in mind. For things that are stored in storage, they're a lot faster because it is right next to it there on disk. And also one of the pros is you don't have to go ahead and set up a catalog. If you've just got an S3 bucket, you just want to dump a bunch of data in there, you can just do that with Hudi and Delta. You don't need to set up a catalog. But if it isn't a catalog, you can start doing fun things like multi-table transactions. So if you need to make 2 changes to a table exactly at the same time, you can do that with Iceberg. In terms of the implications of this does start having some implications on ACID transactions. Remember, these are the things that determine if it fails really bad. No half rights, no half failures. And in terms of how well this is done, it is kind of open to interpretation. There was a real ding-dong online a while ago about who does it better between Iceberg and Hudi. And there was lots of technical discourse. And I'm going to be really honest. For 99% of you, even 99.99% of users, there was a real extreme cases. And is it all ACID compliant? Yes. Yes, it is. Unless you are setting up an experiment to really catch someone out, they're not going to come across it, ever. Another impact of this implementation is actually the ability to go back in time and to time travel as well. And because Iceberg is catalog level, you can time travel at a catalog level. You can do multi-table rollbacks and be like, hey, sorry, we let Jimmy the intern in on Friday. Can you just undo everything he's done? You can do that with Iceberg. OK, in terms of organizing the metadata, so we have this idea of checkpointing. Woo. Don't drink and talk, people. But we also have this idea of how do we go and clean up old files? And they have very specific things. They are a little bit nuanced about what triggers an automatic one. But yeah, all 3 projects have something like this as well. In terms of sorting your data, so if you are compacting it, you want to tidy up a little bit. This is how we are going to solve it. So we have compaction. We are going to take those tiny files, and we are going to make them bigger. And we have different ways of doing this. We can organize our data with various different algorithms. If you're not familiar with Z ordering or Hilbert curves, here we go. Yeah, we're in nerd corner. OK. In terms of whether they're incremental or not, whether this is something that you have to decide as you're doing your compaction, or whether this is something that as something comes in, you can kind of roughly be like, yeah, I think it goes over here. You can do that with 2 of the projects. In terms of deletion vectors, again, this idea of just tombstoning a record rather than, again, having to write in the entire Parquet file and writing out again. We've all got support for that. Now, one of the biggest things that makes Hudi different from Iceberg and Delta is this idea of merge on read or copy on write. These are 2 different types of table, and when you make a table in Hudi, you have to pick whether it's going to be one or the other. And what does that look like in practice? So if this is copy on write, we have our different file groups that we've got here. Let's say we've done a compaction, and we've got our different files with the different groups. If we then go ahead and do a quick read from, that's fairly simple. We just go ahead and we read from it, and it's fine. If we did an upsert where we change these particular records a few minutes later, but if we do a select count star from the table, it's always going to take the latest version. Now, you might think, Holly, this is completely great. This one is slower compared to the other alternative, which is really fast for appends. And this is where things get a little bit trickier. So we've got a compaction here, and then we just do a bunch of appends. This then appears in the append logs rather than the file itself. We carry on doing some appends. We do an upsert. We've got a commit that happens here. And this is the thing that I find kind of strange. So at 10.11, you could do this and not get that committed data. But if you had a real-time table, you would get a merge as you did the read. Now, if this doesn't make any sense, this is completely fine. But the point is you have to pick one or the other whenever you're doing this. And then finally, one of the things that is nice about Hudi, we talked about a Bloom filter index earlier. Other indexes are available, indexes. And it has a multimodal way of doing that as well. And if you're thinking right now that, my God, Holly, this is a lot of stuff that I need to think about and all I wanted to do was store some data, you would be right. I do want to highlight this point quite intensely. This is a load of hidden underneath stuff that you need to think about, and maybe, sorry, I think the gentleman would like another beer? Yeah? Yeah? Send the box round, maybe? Yeah? So if you're after simplification and you don't want to learn and remember all of this, oh, have you got a beer Moretti? Oh, thanks. Thank you. Swag for this gentleman. Because you want to get some beer instead of think about table formats. Oh yeah, this is really hard. And then finally, the design choice we have about number 4 is about how to actually manage a schema. And so, oh, I missed the chance to do my joke. We have a data storage problem. Okay, that's really wearing thin, isn't it? Okay. And there is something that's a little bit interesting here. Yes, it's all stored in metadata, and yes, it's all enforced on write, so you can't lie to it about what is going in here. You do have some interesting quirks in the way that the schema is stored because of how Hudi actually stores that schema by position rather than canonical ID. Right, we don't care. It's in the details there. And then finally, one of the things that we also have as a design choice is the ecosystem. They are thriving ecosystems. They have huge amounts of integrations, although Iceberg doesn't have a nice diagram for some strange reason, so I've just got to list a bunch of stuff here. And when we talk about integrations, it's not just the storage about like the cloud storage or maybe even on-prem storage, actually. Who do you want to process this engine or the data? What catalog, orchestration platforms, blah, blah, blah. There is a lot of arguments about this, and I do feel like it's a real no true Scotsman of like, oh, it's not really an open source project because actually the contributors came from this company. And like, you're always going to find quibbles when it comes to that. Again, not to be too disparaging, but I do find that a lot of those arguments don't come from people who are contributors. All right, so let's summarize. Who's the bestest? And if we think about what our problems that we're trying to solve were, all of them do this. Like, all of them solve the ACID problem. All of them have that schema enforcement where you can't lie to it about what's in your data and corrupt your data and end up with some really bad data quality. They all solve the small data problems, and they've all got that schema evolution as well. Now, very highlighted here, this is my opinion. This is a means to an end. I hope I've really drilled that in this evening, that if you're trying to solve a data problem, you are unlikely to really care about some of the minutiae of the stuff that we have spoken about today. There is an enormous overlap in features. Now, the Venn diagram is not a circle, but it's close. And if you have a rubbish project, a new table format is not going to solve this. If you are doing some janky POC where it's never going to be successful, but you spend 6 weeks deciding which table format to choose, that's probably not going to save it unless you have some really specific problems that we've talked about this evening. And so my advice to you is solve for the data problems you have. Now, there is a bit of an evolution here in terms of, like, what about multi-formats? Like, if they've all got metadata, and 99% of this table format is made up with those base Parquet files anyway, with a little sliver of metadata on top, maybe we could share that between the different projects. So there are some approaches that people have. So OneHouse can help you change between all of them and have different readers. There is also an emerging trend of interoperability as well, so that if you've got like a Delta table or an Iceberg table, you should be able to read it as those as well. All right then, so the big question, who's won? And it's you, the community. community. You get all of these projects for free. They are heavily contributed to. You're going to get more updates to these projects than you will any enterprise software that you might be using. And so I hope you all get the chance to explore these. Thank you. Good night.
All right, does everyone have a drink in their hands? It's not many. It's not many. Right, you guys stayed for the nerdy talk by Holly, but you're going to stay on for the fun AI talk. Oh, come on. Where's the woo? That's it. Now, I love this user group, right? Because every time I ask the next question, I see more hands. So how many of us in the audience are implementing AI or Gen AI or machine learning? Oh, just cheat. Just lie. Make me happy. Come on. I've had a long day today. Cool. That's enough hands. Right, brilliant, because I've got 5 cool new AI updates, all by Databricks. That's going to not only help your agentic framework that you're implementing, but also your traditional machine learning, your data science stuff. Okay? Ready? Right. So in order of the release, the first release that I'm very excited about is the OpenAI GPT open source model. Now, who's heard about this? Brilliant. Are you guys using it? No, you are. I've got one hand in the audience. Now, we've tried it. Now, I'm Gavi, by the way. I forgot to introduce myself. I do not work for Databricks. I do not work for Databricks, but I'm a Databricks MVP, and I'm very proud of that. I work for Advancing Analytics. Yeah, come on, Advancing. There's more people in the crowd. And we are a consultancy, but so we play around a lot with Gen AI. I say play, but we are probably one of the only small consultancies that have productionized 5 Gen AI systems. So when I present these updates at this user group, I'm very, very excited by it because I use it day in and day out. Now, this OSS GPT models is brilliant. So if you're working in a highly regulated industry, like your finance, this is going to come in very, very handy. Now, Databricks has made it super easy for us. You don't have to manage GPUs. You don't have to deploy your own infrastructures. You can use open source GPT models by OpenAI within Databricks. So you can go onto AI Playground and you can use the two GPT models, the 120 billion parameter models and the 20 billion parameter models, very, very easily. Now, if you're using it within your Mosaic AI as well, then your governance comes in for free. And that is brilliant, right? So in terms of why does it matter? Why am I talking about it? Why am I really excited about it? Besides not having to deploy GPU clusters and manage my own infrastructures, using open source models within Databricks, it keeps all your data within Databricks. So, did I hear a yay? No? I'm hearing things. And that's a good thing, right? We work with a lot of financial industries, and their main concern is, hey, what's happening with my data, Gavi? Where's my data going? Even if I'm talking to, for example, cloud LLMs, I don't want my data or my prompt ever leaving Databricks, right? That's the main problem, governance, governance, governance when it comes to Gen AI. By using open source models within Databricks, this solves your problem. And I am a secret fan, I say secret, because the open source models are pretty performant, very, very quick, and they're very, very good. So if you haven't tried it, then go back tonight. Besides telling your other half that you've listened to a nerdy data engineering talk, you can then say, I'm going to try out the open source models. Now, I've got a LinkedIn post out in terms of talking about which LLM to use, open source versus proprietary LLMs. And I get this question, well, we get this question as a consultancy every single day. Which one should we use? I appreciate that's quite small, but if you want to know more, then you got to connect with me on LinkedIn. Hey, free marketing. But anyway, I like to always give you some context, right, why I'm so excited about it and where we're using it as a consultancy. And as a consultancy, we've kind of found 3 places that these open source models can be leveraged. So if you are working, trying to implement chatbots and agents, using open source model within your lakehouse, brilliant idea. Document processing. If you're summarizing legal contracts and you don't want your legal contracts to leave Databricks, using open source models all governed within Databricks, another brilliant idea. And the last thing is fine tuning, right? So in the legal industry, they're very, very concerned about their jargon. I don't get it. But you can get an open source model, you can fine tune it on underwriting and call transcripts and use it that way. So that's another brilliant way. So, second announcement, and this is probably my favorite announcement for the last 2 months. That's the Mosaic AI Vector Search. Who's used the Vector Search? Only one, two. Alex, I know you've used the Vector Search. Your hands are not up, but I know you've used the Vector Search. Re-ranker. Now, why am I so excited about the re-ranker? It's just not moving. Okay, it's moving too fast. Right, so if you imagine, when we didn't have the re-ranker, I'll give you an analogy. It's like all of us walking into a library and asking the librarian for climate change books. Now, if you use the traditional vector search, the librarian is going to give you 10 books of climate change, right? So it's close enough to what you've requested. But with re-ranker, it's got another model on top of vector search. So what it does is it says, well, you asked for climate change, but out of these 10 books, these 5 books are going to match your search a lot closer. So in terms of accuracy, with re-ranker, you're going to get a lot more accurate results. So if you're playing with RAG frameworks, if you've got a knowledge base implemented in your company or in your business, then you really want to be using re-ranker as a feature. I love the nods. Now, our Databricks has made it very, very, very easy to do this with using just one line of code. And I know they say it's bad practice to show code, but this is really, really cool, right? With just one line, you can enable re-ranker within Databricks. So it's super, super easy. So if you're not using it, if you're using vector search, please use the re-ranker tonight as well. Try it. It's just one line. It's only going to get you 2 seconds. And in terms of accuracy, this is Databricks research, right? It's 89%. So it's very, very good. Now, I've tried it myself, and it's pretty spectacular. Now, in terms of examples, the way we use it, we use re-ranker every single time, every single day, in every single application we help customers implement. Insurance. So if you are searching for historical claims notes, if you do not use re-ranker, you're not going to get accurate results. With re-ranker, you're going to get far more accurate results. And legal, that's another industry that we have used re-ranker with. And we use this in terms of finding the right clauses. And it works very, very well. Cool. Number 3, I've already given you my favorite announcement, is authorize on behalf of user. Now, I'm sure for those of you who love governance, this is probably going to be your favorite announcement. I'm not sure, but we'll have a show of hands later. But with OBO, now the agent acts as you, right? So I like looking at pictures. I'm not going to look at my text. But without OBO, if you had played with agents, then basically your agents have a full view of your delta table. So if you did not want it to see certain information in your table, it still sees it without OBO. And that's bad, not good, not great for governance, not great for auditability. It's bad, bad news, right? I think this was announced on the 5th of September, maybe 3rd of September, but with OBO, when we implement agents now, your agents only sees what you're allowed to see. So for example, if you had implemented a finance agent and you've got a table that you only allowed certain people and therefore your agents to see, it will only able to access that particular table. And that's pretty cool. And very, very important when it comes to Gen AI applications in terms of governance, auditability, understanding what your agency, this is critical. So a lot of people are excited about OBO, but I was excited about number 2, not number 3. Right. Yeah, I was going to say, right, this solves the biggest barrier to deploying agents in regulated sectors because they always need people, users, or agents to only see what they're allowed to see. But with OBO, it solves the problem. I say number 2 was my favorite. I think number 4 is a big contender. Data science agent. I think Marius, where's Marius? I was talking to him before, and I think this was his favorite announcement. And this is pretty cool, right? So I'm going to talk about the machine learning lifecycle. How many of us here have actually built machine learning models? Painful? Very painful, right? I'm going to go through the life cycle. You have your data, you clean your data, then you do feature engineering, and this is where I struggle with because there's so many different ways that you can do feature engineering, and you do your model selection. Then once you choose your model, it doesn't stop there, right? You got to tune it, you got to train it, you got to validate it, and guess what? That loop can be endless. As much as I enjoy doing it, it can take hours, right? It is an iterative process. It's time-consuming, often very, very, very tedious. However, with a data science agent, I'm going back. It's pretty cool. Very, very easy to enable within Databricks. And honestly, I tried this last night. Within 10 minutes, all you have to do is point it to a table, tell it what you want it to analyze, tell it what columns you want it to see, and it will automatically plan, orchestrate it, build your machine learning models with governance, with ML flow, all under 10 minutes, I guarantee you. That's another thing you've got to try tonight. So after your nerdy talk, telling your partner what you've done, you've got about 15 minutes of cool AI stuff to try out tonight. But this is really, really cool, right? And if you're thinking, well, Gavi, I've seen that on the Databricks demo. You really have not tried this. I have, and it's pretty cool. Now, this is going to be very nerdy, but I call my notebook something very abstract, and the agent recognized the machine learning model that it built for me didn't correlate with the notebook, and it changed it live. And I thought, wow, that's impressive. That's really cool. In terms of what it did for me, right, it did all the EDA, which can take people hours to do if you're a data scientist. It built a model, and not only did it build a model, it built the best model for me, hosted it on MLflow automatically, and it also commented my code that I don't often do. Bad practice, but perfect, right? So if you haven't tried the data science agent, that's something cool to try out today as well. Right, number 5 is MLflow metadata. Now, this is also cool, very cool announcement. It's probably the latest announcement, right? I'm just going to give you a quick update. Before MLflow metadata, you could access information that MLflow was tracking, but you had to use the Python SDK or the REST API. But now it gets automatically written to the table. So it's accessible from one single place. And that's very, very, very helpful. So for example, if you wanted to understand your runs, your experiments, your parameters, your metrics and tags, you can use SQL, like how you'd access any tables within Databricks, and you can get that information out very quickly, right? You can also plug it directly into dashboards. So you can have alerts set up. So if there's a metric that's falling below a certain threshold, that can be automatically alerted. And that's very, very, very powerful, right? It never used to be so easy, but it is very, very easy now. But in terms of GenAI applications, I think this is where the power comes in. MLflow metadata lets you track prompt performance, monitor cost, compare models, set alerts when quality drops, and you don't have to fish it out using Python and the REST API anymore. It's all written to a table, so it's super, super easy. So those are my 5 announcements. I'm going to get you guys to vote. Got smiles. Which was your favorite? Number 4. What was number 4? Oh, the data science stuff. Cool. Number 3, that's with me. No, not with me. Oh, the OBO, the governance. So we got 1, number 4. No, come on, guys. I'm sure most of you listened to what I was saying for the last 10 minutes. Number 3, number 4, number 3, number 2. That's with me. I like you. We'll have a drink. Yeah. 5. That's boring. Cool. All right. My favorite was with you. Yeah. Number 2. Brilliant. My favorite was number 2. But yeah, that was a 5 AI announcements team, and that's it. That's the end. I think we have a Q&A session hosted by Simon himself. Yeah.